Hello and welcome to our video on section 10.3, polar coordinates. This will be the first of a couple videos. This one will just take us through what polar coordinates are, how to calculate them, how to convert back and forth between polar mode and Cartesian mode or rectangular mode, and all of that. Then we'll get into some of the calculus of it in future videos. So first of all, just kind of read some of this to you so we can go along together. The polar coordinate system in the plane consists of points r, theta, where r is the distance of the point from the pole, which is really the origin, and theta is the angle formed with the polar axis, or that positive x-axis. This is no different from the trig that you studied. What that means is if that is our polar axis, right, positive x-axis, we have always found the positive theta to be a rotation, right, up into that first quadrant, and there's my theta. And so we could continue and put our triangle over here if we wanted into the second quadrant, etc. If we wanted to, we could have negative thetas, and that meant that instead of heading up into the first quadrant for our triangle, I'll talk about that triangle here in a second, if theta is negative, we rotate down into the fourth. And so maybe my triangle looks something like so. Okay? All right, so I'm going to take that triangle off just temporarily because I don't need it. And what we're going to look at is this point up here in rectangular or Cartesian mode would be xy. And there is only one unique way of writing each point xy, okay, to get to that specific point. But there's actually going to be an infinite number of ways that I can write that same point in polar mode, which we're going to talk about. So if you think back to trig, I want you to think back to something called coterminal angles. And what that meant was, if this is how you get to your original theta, and I'll delete the other extra piece here, right? If that's how you get to your theta, by starting at the polar axis or by starting on the positive x-axis and rotating up, here's your triangle that we're drawing. And if that's how you get to theta, another coterminal or same terminal side could have been used with a completely different theta where you go around once and then go that amount. If you are talking in radians, you're going all the way around 2 pi. If you're talking in degrees, you're going 360 degrees, and then plus whatever theta was. So I can write this an infinite number of ways. I can go around again, go around again. We talk about coterminal angles. I could go in the negative direction and then go negative all the way around again, all the way around again. So that's what's going to be convenient about working with these polar coordinates. Also, we don't always measure things in real life by how far we went over horizontally and then how far we went up vertically. And that's what that point PXY tells us. Oftentimes, like let's say we're looking at a two-dimensional map of the United States, and if I wanted to fly from, we'll call that pole or origin Phoenix to, let's say, Chicago, right, my point XY, well, I need to figure out in what direction do I need to travel and for how long. So that's that theta and that r value. Then we'll talk about, and I'll show you some negative r's here. So I'm going to scroll this down. And we're going to look at this graph for a second. So this is really the same thing, just kind of parceled out. So don't look at this part just for a second. Just look at that angle there that I'm showing you. And if this is theta, right? And so my point up here would be r comma theta. R would be the length of this segment, okay? And theta is the degree from the positive x-axis, whether it's in degrees or radians. It's the measure of that angle. So now let's talk about what a negative r represents. There are such things as negative radii. So I know back in the day when you studied x squared plus y squared equals 25, we should recognize this equation as a circle and it has radius 5. And really, we said this stems from the fact that x squared plus y squared equals r squared. So we were really kind of in our heads solving the equation r squared equals 25. Now, why we only put r equals 5 is because you were in rectangular or Cartesian mode, so we didn't have a way of looking at a negative or opposite of that radius. But really, algebraically, there is plus or minus there. So now polar mode is going to allow us to talk about that negative r. So that's where this graph comes in. So we're going to take a look at this. Negative always has meant opposite. So if we look at a number line and we have 0 and we have a 1 and we go to the right to go positive 1, we go in the opposite direction to get to the negative 1. It has always meant opposite of 1 or opposite of whatever value I have. So that's the same thing here. It still means opposite. So what happens is once we look at what is the r theta right here, okay, for the original theta with that original given r value, if I wanted to look at how to write things and end up in the same spot, I can do that. But if I just change r, I don't end up in the same spot because I end up on what's called that opposite segment over here with a length of r still, right? Its length or its distance is still r, but it's mapped out as a negative r because it's the opposite direction. So it would be like you extending that segment out and doubling its length, right? Or it's as if you're looking at a number line and let's say that's 0, maybe you consider this side negative r and that side r, and that would be fine as well. That might seem a little confusing right now. I think we'll clarify all that as we draw these. And then the other important thing to note here, let me see if I can get it all on the screen. There are many different ways to write the coordinates of the same point with polar coordinates. So they might tell us to specifically pull out some thetas that are only between 0 and 2 pi, or maybe they want us specifically to have a negative theta or to have a negative r. So we'll have to pay attention to those directions as we answer the questions. Okay, so let's just start plotting some of these. This is typical polar mode, if you will, or polar graph paper. You can certainly Google it and find some, or you don't actually need it because here is your y-axis. Oops, it's not straight, sorry. And here is your x-axis or the polar axis. And if we know about trigonometry, we start at 0, we rotate 90 degrees or pi over 2. Here's 1 whole pi, and here's 1.5 pi. And then we come back around and we complete our cycle. And we can keep going, certainly, but I would just stop there. Also, the y-axis sort of just gets in our way, but a lot of us use it for, is it bigger than a half or less than a half in terms of pi? So that might help you plot, maybe, maybe not. So we're going to plot some of these. So the first one we're going to plot is 1, 5 pi over 4. Okay, and then we'll find 2 other pairs, and I'll read those directions with you in a second. But we're going to plot this first. So it has a radius of 1, and it has an angle of 5 pi over 4. So each of these circles, here's a circle with radius 1, here's a circle of radius 2, here's a circle of radius 3, and so forth. Okay? So I'm going to be on that innermost circle, and I have to find 5 pi over 4. Well, in terms of a whole pi, this is 4 pi over 4. So I'm 1 pi over 4, or halfway past pi. So let's see if I can, oops, I went too far, with a radius of 1. And so I don't actually need the polar paper or polar graph, if you will, because you've always just sort of drawn those on your own anyway. And the 5 pi over 4 is achieved by going all the way around, starting at that positive axis. So I end up in quadrant 3. And that's really important to know, because if you're ever finding the rectangular point to match that, you want to make sure that point is also in quadrant 3. If you are rewriting this, you want to make sure that any way that you write this one point, you end up back in quadrant 3. So, for example, it says, after you plot it, then find 2 other pairs of polar coordinates of this point. So I'm not moving the point. I'm staying in quadrant 3. One with r positive and one with r negative. So if I stay with the same type of r that I have now, r being 1, all I have to do is find coterminal. So a coterminal angle to 5 pi over 4 would be adding 2 pi. Just go around again. And same thing, I could have subtracted 2 pi, but you add or subtract 2 pi. So if I add 2 pi, add 8/4, so that would be 13 pi over 4. If I had subtracted 2 pi, I would subtract 8 pi over 4, and so I would have ended up at negative 3 pi over 4. Either one of those would be fine, because they didn't tell me what theta had to be. They just were dictating what r had to be. And then for my other one, they tell me one where r is negative. The r being negative means that I have to use the opposite segment, right? But then if you're saying opposite, it's going to push you back onto the other side. So if I use 1 pi over 4, this would be quadrant 1, right? Because pi over 4 is in quadrant 1 right there. But the negative r is going to tell me to go to the opposite side of that segment. So if you were in quadrant 1, you're now in quadrant 3. And the same thing will be true if you have a point in quadrant 2. The negative r is going to jump you down into quadrant 4. So 1 is going to put you in 3, and 2 is going to put you in 4 for that negative r, and vice versa. Okay, so these are other ways of writing. Here's my negative r, and here's an example with a positive r. All right, so let's do this again. If I'm plotting the point 2, 3 pi over 2, the 2 is my radius, so I want to go out 2, and you may absolutely darken these, because if you're doing this on your own paper, you probably are just going to draw this y-axis and this x-axis. Okay, so 2 is going to put me on the second ring, right, radius of 2. And if theta is negative 3 pi over 2, I'm rotating down this way. So negative 1 pi over 2 brings me to this axis. Negative 2 pi over 2 brings me to that negative x-axis. And then negative 3 pi over 2 actually puts me up here. So I'm actually on the positive y-axis. If you weren't sure, you can always add 2 pi to make your angle positive, because then I would be adding 4 pi over 2. So this could be the same as 2 comma 1 pi over 2. And in fact, that would be one of my answers, because that's another way to write this point with the same r value. Okay, so I'm just going to get rid of these, because these were kind of the on the ways, right? Now, if I want to figure out what is the point for the negative r, right now I'm up here on the positive y-axis, radius of 2. So if I want to figure out what does that opposite segment look like, I'm down here on the negative y-axis. And so what that looks like, I can say this one of two ways. I can say negative pi over 2, or I could say it's paired with a positive 3 pi over 2. Either way, you have a negative r. Now, if you'll notice, the relationship between my positive r and my negative r, I'll use this one, the thetas will always be pi apart. And let's think about why that is. They're always pi apart because you're forming a line. And a line is 180 degrees or pi in radians. So that's going to make sense. So that's how some people do it as well. Okay, so last one here. What if I gave you or started with a negative r value? So you're going to start with theta, right? So I'm going to go to 3 pi over 4. So again, you might want to start with on your paper here, with your axes. Okay, so 3 pi over 4, again, 1 pi over 4 is going to cut the quadrant in half, 2 pi over 4, so 3 pi over 4, sorry. So I'm going to move up my radius to be 3, and I'm going to dash it, or just try to draw it maybe a little lighter. 1, 2, 3. So I think I'm right here, but then when I really look at it, I have a negative r value. So that means opposite segment. So instead of being at the 3 pi over 4, I'm down here at negative, at negative pi over 4, or you can just look at it as that in the fourth quadrant. It's not letting me draw very nicely. There it is. So this is my point, right, with a radius of 3. Again, I'm just looking at that as in determining its length. Would be 3 pi over 4 would put me up here, but because it's paired with that negative r, I'm on the opposite segment. So because this was in quadrant 2, right, this angle is in quadrant 2, but the point itself is a quadrant 4 point. And again, that's important to note, because if this point is in quadrant 4 and you're going to rewrite it in Cartesian mode, which we're going to do, we're going to write this in rectangular form, then we want to make sure we're in the right quadrant. So if I had to rewrite this two ways, I would say, one, if you keep your r the same, you're just finding coterminals. So I can add 2 pi or subtract 2 pi, which if I add 2 pi, that would be adding 8/4, so this would be 11 pi over 4. And then for the positive r value, again, if I just go there and stop with that opposite business, right? If I just do a positive r value, I can take a look at what is that angle to get there. So that is just that negative pi over 4 that we talked about, or you can say that it is, like I said, if you have this 3 pi over 4 already, you can just add pi, because you know the opposite segment will always be pi apart. So that would be 7 pi over 4. So I could have 3 comma 7 pi over 4 as well. And these two should be the same place because you're saying this or this, right? And they are. Okay, so now that we have a little bit of an idea of plotting, let's talk about some things that we know from pre-calc. Pre-calc meaning anything from before Calc 1, right? So whether you took a trig course or a pre-calc course with trig in it, whatever you had. Let's look at the triangle that I drew at the right, and I'm saying that this, whether it's in polar or rectangular, right, this is what this is going to look like. I like sticking with the horizontal being x, the vertical being y, and therefore the radius or hypotenuse being r. So let's just talk about some basic things that you know. If you want a good challenge, you can pause the video right now and write out all the things that you think you know. Okay, but now we're ready. So I know basic Pythagorean theorem, right? x squared plus y squared equals r squared. I also know, and I know 6 of these. I'm just going to write a few, and you can use more, of course, but I also know trigonometrically sine of theta is opposite, which is y, over hypotenuse. Or if you wanted to multiply both sides by r so you don't have a fraction, it looks like so. R sine theta equals y. And I can do the same thing for cosine theta. So I can say cosine of theta is adjacent, which is x, over hypotenuse, which is r. And again, you can have that same sort of philosophy here, multiply everything by r to have no fractions there. And it's just solve for x and solve for y. So those might be helpful. And lastly, I can do the same thing for tangent. I'm not going to write out the other 3. They're just reciprocals of these 3. So if you were talking about secant, you would have r over x, for example. So tangent of theta is opposite, which is y, over adjacent, which is x. And I don't typically see the need to rewrite that one. That's pretty much what you're going to be using here. I'm not going to put any of the r, positive r to negative r stuff in there. So you can use these relationships to convert between polar coordinates and Cartesian and back and forth. Exact values are going to be expected if those angles come from the unit circle. So if you're talking about pi over 3, pi over 6, etc., you're going to be expected to keep those exact. But you don't actually have to use this idea of that this information is new to solve these problems. I think if you understand that this is your r and this is your theta, now the negative r thing definitely is new here, but if you understand basic trigonometry, like SOHCAHTOA, plotting, recognizing your special right triangles. So when I say basic trigonometry, I'm talking about the basic most identities that you knew. A lot of books even call them basic identities. So I'm certainly not trying to insult you if you don't remember them. I'm just trying to give you something to, I guess, Google if you don't know something. So I'm going to sketch this first. It's really important to know where your point is to figure out if your answer is even going to be correct. So if I plotted this, and again, I don't need the polar paper because I'm just working off basic plotting. So if I look at 5 pi over 6, 1 whole pi is 6/6, so 5 pi over 6 would look something like so, with a length of 3, but it says -3. So I'm actually over here on the opposite side of that. So here's where my point is. So this is a quadrant 4 point. And so now what I'm going to do is actually just enclose this angle. It's a pi over 6 triangle, which means this angle in here is 30 degrees, if I put it in degrees. If I think about it with a radius of 1, so just humor me for a second. I know some of you learned this with a radius of 2. I have very good reasons right now to have your radius be a 1. So if your radius is 1, or hypotenuse, then what you can do is write the other two sides ratios. So opposite your 30 degrees is always 1/2, and then opposite your 60, or your other side, is always square root of 3 over 2. So I'll label that. And then I go through and label my positives and negatives. So because I'm in the 4th quadrant, I go to the right, so the x is positive, but I go down, so that y value should be negative. And then you don't have a hypotenuse of 1, you have a hypotenuse of 3. So I just go through and multiply all 3 sides by 3. And now I know exactly what this point is in rectangular mode. It's 3 rad 3 over 2, comma, -3/2. and I did not need a formula to tell me that. I just needed to know some of my trigonometry to do that. If you did use the formula, you come out with the same thing. You have a formula for x now that we just wrote above in that box. X equals r cosine theta, and I'll skip a space here. Y equals r sine theta. You don't even have to convert to positive r's. You can just leave it as is. R is negative 3 cosine of 5 pi over 6. Now, again, you have to know what the cosine of 5 pi over 6 is. This one would be, because you're in the second quadrant over here, it would be negative square root of 3 over 2. And that's where I get positive 3 rad 3 over 2. And then the same thing would occur for y. Y equals negative 3 sine theta, which is 5 pi over 6. And so that would be negative 3 times positive 1/2, because if you're up here in the second, your y value would be positive. So I get the same answer either way. I just think that sometimes we get stuck on memorizing formulas, and this is not anything new. Okay, so 2 comma negative 5 pi over 4. Don't get too panicked. Every time you see a negative, it does not mean opposite segments. You don't have to worry about switching quadrants. This is literally just a negative angle. So when I start my rotation from my positive x-axis at 0, I do not go up into the first quadrant. I go down into the fourth and around that way. So I'm actually calculating this or finding this triangle clockwise at this point. So negative 5 pi over 4, well, here would still be pi, and that's why I like just doing the x-axis sometimes, labeling. So I'm going to go this way. Here's negative 4 pi over 4, and then I have to go an additional 1, so I should be up here in quadrant 2. Right, because you're rotating around this way. Okay. And this is a pi over 4, so this is a 45-degree triangle in quadrant 2. It has a radius of 2. I'll deal with that in a second. I start with all of my hypotenuse or radii to be 1, because then you can multiply or scalar up this triangle or scale down this triangle and multiply all three sides by any value. As long as you do it to all three sides, you're just scaling it up or scaling it down. So if it's 45, 45, 90, these other sides are square root of 2 over 2. And then again, you need to put your positive and negatives based on the quadrant that you're in, because you're just trying to really get to that point up there that I just labeled. So my x value is negative since I was heading left. My y value, though, is positive since I'm going up. But again, I don't have a radius of 1. I have a radius, in this case, of 2. So I'm going to multiply all three sides by 2. So if I were to write this out as a point, x comma y, here's my x, so it's just negative rad 2, and then my y, positive square root of 2. And again, the formulas could have gotten me that as well. That's just up to you. Okay, so now let's go backwards. I'm going to give you Cartesian coordinates, and I want you to find the polar coordinates r theta. And when they ask you to do this, since there's more than one way to write the polar coordinates, remember there's an infinite number of polar coordinates to represent any one unique rectangular coordinate. So if that's the case, they're going to specify how they want it. And this time they're saying 1 r is greater than 0. So 1 r is positive, where theta is also on its first rotation, so from 0 to 2 pi. And then we want a second answer here where r is negative, but we're also going to restrict theta to be on its first rotation, or in other words, from 0 to 2 pi. So the first thing that I literally want you to do is exactly what we did when it was in polar, is I want you to just plot it. This is a rectangular point, negative square root of 3. Again, this is my y-axis, this is my x-axis, so negative square root of 3, -1, right? Because this is a y value. So here's my triangle. So we wrote down, some of the things that we know about right triangles, because this certainly is a right triangle. Here's some theta in here as a reference angle. Well, I know Pythagorean theorem, so I can just use that. Negative square root of 3 squared plus the quantity -1 squared equals that radius squared. So it's 3 plus 1. So I do have plus or minus 2, right? Square root of 4 is the radius. And again, square root of 4 is just 2, but I get the plus or minus because of the r squared. So I'm just going to call this 2 for now. And no matter what it is, I like seeing the radius or hypotenuse as 1. So all I would do is just divide by whatever that is, and there are my special sides that I should know. Opposite of 1/2 is always a 30 degree. Opposite the rad 3 over 2 is always the 60 degree. But you're always going to be talking about that angle formed with the pole or the origin. So the way that I get there is I go to pi, right, because I start at 0. I rotate to pi, and then I go 30 additional degrees, or pi over 6 degrees. And before I go too far, I should say that I think it is really important to note, just like we did before, what quadrant we want to end up in. And surely, based on my triangle and where this point is, I want to end up in quadrant 3. So I think my angle is going to come from pi plus pi over 6. And so that would be 7 pi over 6. So I can associate this with the positive r. I'm not talking about the opposite side of the segment or anything like that yet. And that should get me to this point, which it does. And the 7 pi over 6 fits that description that we need to be on our first rotation, right, between 0 and 2 pi, and I am. So then my next one is, okay, what if I have a negative r? Well, I need to be on the opposite segment, right? So when I first plot it, you would be going to the first quadrant, then the opposite r would send you automatically down there to the third. So this would be forming a line, and if I added pi to the angle, I'd be adding 6, and I would get 13 pi over 6. And most, computer systems, etc., will tell you that you're wrong, and you're probably not sure why. Because you're like, no, it makes perfect sense. It is one potential polar coordinate, but they specifically wanted you to only go around one time, and 13 pi over 6 is bigger than 2 pi. This is 2 pi and 1/6 pi. So it's too big. So what you want to do is if your opposite r, for example, ends up like this just in quadrant 1, just make sure it's a real tiny angle, just between 0 and 90 degrees, for example, or 0 and pi over 2. So instead of adding pi, I'm going to subtract pi. And so I'm subtracting 6, so it's just literally 1 pi over 6. And again, these are still pi apart, right? Because if I add 6 to pi over 6, I get 7 pi over 6. And I'm going to show you something interesting here about if you are only formula based, how this can actually hurt you. So these are our two answers, and they are correct. If we are formula driven and using the relationships that we wrote down in that box earlier, we know we can solve for theta by using this formula right here, that tangent of theta equals y over x, because I'm given y and I'm given x, right? So I know tangent of theta is -1 over negative rad 3. And even if you simplify this and say tangent of theta is 1 over rad 3, if you're only using technology, I think you're going to run into a bit of a snag. Let me show you. So if I go to my calculator, and when you're solving tangent of theta for theta, you want to do inverse tangent of both sides. So I will do inverse tangent of 1 over square root of 3 and see what I get. And now most people recognize, oh, but you're in radian mode. Okay, so let's multiply by 180 over pi, 30 degrees, which people know is pi over 6. But what happens is you get the pi over 6, right? Okay, great. Theta is pi over 6. Check, that is correct. But you are still not sure which r is that paired with, the positive or the negative. I guess you have a 50-50 shot. Well, if you know that your point is in quadrant 3, that's where you have to pair that with other knowledge that you have. You can't solely rely on the calculator. But if you pair that with other knowledge that you know that you're in quadrant 3, then for sure you know the quadrant 1 angle needs to be paired with the negative r. So I would say, okay, negative, and I find r by simply doing the Pythagorean theorem that we did before. And so I would say it's negative 2 comma pi over 6, etc. No matter how many times you do inverse tangent on your calculator, it will not give you 7 pi over 6 as default. Inverse in your calculator stays in function mode, so it tells you the first time that your theta will give you that ratio. And the first time that that happens is in quadrant 1, not quadrant 3. Okay, so now what if the numbers aren't exactly nice? You can still keep your answers nice. So let's look at this one, 3, 4. So x is 3, y is 4. I'm up here in quadrant 1. And what do I mean when I say the answers aren't necessarily nice here? Well, this is a 3, 4, 5 right triangle. If you don't believe me, you can do Pythagorean Theorem, right, and solve for r. Again, I'm going to have one point where r is positive. Oops, I'm going to need a bigger space for that. And I'm going to need one point where r is negative, okay? So now what? If I'm trying to find theta, that is not a theta that I am familiar with. That is not a 30, 60, 90. That is not a 45, 45, 90, etc. So all this is this is based off of your tangent of theta equals opposite, which is 4, over adjacent, which is 3. So yes, if you take the inverse tangent of both sides, you will solve for theta. But you have to make sure that this theta, which r is it paired with? The positive r or the negative r? Okay? So what I would absolutely do at that point is go back to my calculator if you need to, and figure out what inverse tangent, because most people don't know this number in their head, right? This isn't necessarily a number we're supposed to know. 0.927. And then I can figure out, if I don't already know, what pi over 2 is, which is 1.57. So that theta is in quadrant 1. Okay, so I want to pair that with my positive r value, because that's exactly where I want to be. And I literally, if I want to keep it exact, that is theta. Inverse tangent of 4/3. So to get the negative r, you add or subtract pi. Now remember, this was only like a 0.9 number. So if I add pi, I'm adding 3.14 to that. I mean, it goes on forever. And so I'm still only at 4 point something, so I'm not going to quite go all the way around. So this is going to be perfect, and I'm going to say pi plus inverse tangent of 4/3. And literally, if you're asked to keep it exact, that is it. You're not necessarily coming up with that decimal version. Okay, that'll be it for this video. We're going to graph some polar curves because I also want to take you through on your graphing calculator, switching it to polar mode, and all of the window changes and some of the calculations that we will need to do in polar mode using your graphing calculator. So that video will come next. I hope you found this helpful to start you off with polar mode.